For joining. Today we are going to talk about GenAI based ETL and visualization. This is a very interesting use case that I have come across, and I will explain the value that GenAI brings into creation of ETL pipeline without having to do a lot of work, and how you can visualize the data which is prepared at the end of the ETL pipeline for getting the insight in a very intuitive manner. This is the series where we've discussed about RAG. Today we are going to talk about ETL, and the last session is going to be on fine-tuning models. As usual, I'm going to discuss some concepts with help of technology. I will demonstrate, and I am keeping these sessions purposely at a conceptual level for the benefit of a wider audience, and whatever I talk about is backed up by demos so that there's a confidence in what I say. These sessions are basically provide a high level view, but I'm open to more detailed view if you require. And I use Azure platform. In this case, I'm using Azure OpenAI to leverage GenAI model. But whatever I say is open and using frameworks, languages, and tool set which are predominantly open source. I've got a group on LinkedIn where I post useful insight, market, and technology information. Feel free to join in case you have not joined so far. Prior to this, I had two series, and I've got recordings for people who could not attend. The link to all this material and the recording is in the invite. If you feel like starting from the scratch, you can go through them as per your convenience. Now, let's talk about first, just to be setting the context, the difference between OLTP and OLAP application. OLTP essentially are these applications that we have in enterprises which performs business processes. All your systems, CRM, your contact center applications, order management, inventory management falls into that category. There's another breed of application which falls into category of online analytical processing, which deals with business intelligence. And if you look at the comparison between OLTP and OLAP applications, OLTP applications handles large amount of data, which is more transactional in nature as compared to OLAP, which is used for data analysis and generating some business intelligence. OLTP systems are transactional, like I said. They are basically involves creating business objects, modifying them based on the need. Whereas OLAPs basically look at a larger set of data in order to generate valuable information. For OLTP systems, there are small transactions which are very atomic in nature, very fast in terms of processing, whereas OLAP systems predominantly deals with a large data set, and unlike OLTP, the performance is not a transactions performance, but is more in terms of the query performance, how quickly you can actually get the insight. The examples for OLTP system, like I said, ATM transactions, online booking, whereas OLAP systems are used for business reporting, data mining, sales forecasting. So the fundamental focus for OLTP is transactional, whereas OLAPs are basically used for data analysis. And often the source for OLAP data is from the OLTP system, and that's where ETL come into existence. From a data modeling perspective, OLTP uses traditional databases which are relational in nature, whereas the model for OLAP applications are multidimensional, and we'll see that in detail. So, like I said, the focus of OLTP system is essentially to implement a business process, and OLAPs are focused around generating insight and more like a business intelligence kind of a thing. Now, before you actually start getting the insight, you probably have something in between OLTP system and OLAP systems, which is basically the entire pipeline. What we call it is an ETL pipeline. And one of the popular pattern that is used is a Mendelian architecture, which is a multi-hop architecture designed to organize data in a data lake house. And essentially, the objective is to incrementally and progressively improve the structure and the quality of data through each layer, and we'll talk about these layers. So the Mendelian architecture consists of 3 layers, namely bronze layer, silver layer, and gold. And the bronze layer is just an ingestion layer or a staging area where you basically pull out the data from your OLTP applications. In silver layer, you basically clean the data, improve the quality by doing things like filtering, lookups. An idea is to make sure the data is of a good quality. For both bronze and silver layer, in terms of data model, you basically have again similar relational tabular data model. And the final layer, which is the gold layer, which is used for generating the insight, and that feeds into all that analysis, machine learning. This model for gold layer is generally multidimensional, and basically what you have is an aggregated view rather than an atomic view of the data. And let's see how it looks like. So if you see at the bottom, the traditional ETL, you have extraction, you have some staging area, and then you transform and load it into a warehouse to perform analytics. Mendelian architecture is quite similar. So on the left, you see there are various enterprise data sources which supports different different data types and formats. You have events, you have files, you have databases, and then you have document databases if you are using NoSQL like database. So what you do in the bronze layer, you essentially ingest the data as is, and then it feeds into the silver layer where the data is filtered, cleaned, and augmented. And finally, you create a gold layer where you have the data model, which is multi-dimensional. That basically can be used to create a semantic layer which focuses on, let's say, for a business application, you may like to have a semantic layer for sales or inventory or marketing. And that provides the data for analytics, business intelligence, or machine learning. So what we're going to do in this session, we'll go through each of these layers and how GenAI can be leveraged to enhance the productivity to the entire pipeline. Now, the benefit of Medellin architecture, it guarantees atomicity, consistency, isolation, and durability as the data passes through multiple layers. It gets clean, augmented. So what you have at the end of it is really high quality business level data. And basically based on the kind of data that exists and the volatility, it can actually take various forms and degree of normalization. Now, let's look at each layer. The bronze layer contains unvalidated data, which is just the copy of your source data. It is in the same state of the data source. It can be appended incrementally to grow over a period of time. And you can actually get a feed from streaming as well as batch. So streaming, you can use event streaming to populate the bronze layer, or you can run periodic jobs to ingest the data. Now, let's look at what you require to build a bronze layer and how GenAI can really help. So I've got an application that I'm going to show you, which has basically a small Python code. I'm leveraging prompt engineering. And what essentially I'm doing here is how can I create a bronze layer without having to do much coding. And if I just try to explain, I've got some basic Python code, and what essentially I'm doing, I'm creating a prompt which will generate the DDL for the bronze layer, and then through the second prompt I will generate the code to ingest the data from the source databases, and all that is agnostic to the number of tables and the type of data. And let's see how this works in action. Now, what I'm trying to do here, I'm just trying to demonstrate the ETL pipeline creation using GenAI. So, like I shown, there are two prompts that basically help you create the DDL scripts as well as the ETL script that would ingest the data. Now, one of the biggest challenge in GenAI is to really know how things happened, which is called explainability, which is important. So while I'm doing this, I'm keeping a copy of the DDL scripts. Say, for example, we are creating the DDL script, which is essentially the schema for the bronze layer. I can actually verify what has happened in terms of the code. Similarly, I'm also storing the Python code that it has used. If you see here, I'm just showing some progress in terms of some messaging. What was the code that ingested the data from the source database? And that way I can be sure that I understand what the model is doing in terms of generating the code both for schema creation as well as ETL pipeline. And just imagine if I were to do the same thing manually, that means creating DDL scripts and then creating ETL scripts. This could have taken weeks of work to achieve that. And if I have a different requirement where the databases sources are different, I do all the time, the same amount of work. Whereas after writing the 4 code in Python, this I'm able to leverage this across different domains. Now, let's go back to the presentation. So that's basically how easily you can leverage GenAI to do the ETL part. The next step after bronze layer is to create a silver layer. Like I said, the silver layer is used to purify or improve the quality of the data by filtering out something which is not relevant, augmenting it if some values are missing. So end of it, what you get is a much cleaner data. Again, for doing that, you can leverage GenAI. So what you essentially would do here, if I show you the code from bronze to silver, similar prompt engineering, you provide the source of the database and also provide the right kind of logic in terms of implementing data quality. Again, you can specify how you deal with null values, missing values, how do you filter out, and all that can be done through the prompt engineering. This would really result into a very high productivity and it really make things very efficient. And not only for one project, once this framework is ready, you can really reuse that because it is agnostic of the database technologies and the number of tables, and that really makes it really very useful. Now, once you create the silver layer, you with that clean data, you like to create what is called as a gold layer. It is essentially the data which is highly refined and aggregated that is used as an input for your analytics workloads. And the two predominant models that is used for the gold layer is Snowflake and Schema. They essentially the data models which supports query which are very efficient. So what you have a concept called, if you are not familiar, which is dimensions and the facts. Now, dimensions are like this. If you see on the left, these are the perspective on which you would like to do the analysis. Facts are essential the numerical value that you would like to analyze from that perspective. So if you see here, we have a dimension called customer, store, date, product, and for these dimensions, you have a fact table which has a number of columns representing some values. For example, you want to see the customer-wise sales or store-wise sales, and uh, sales for a given period, which is quarter and a year, product-wise sales. So these are the different dimension on which you would like to do what is called slicing, dicing, drill through, and drill down. Star schema is small is a variant of Snowflake, but essentially what you have is a view which is different than what typically old TP system would have as their data model, which are essentially tables related to each other through referential integrity. Now, let's look at how we can leverage GenAI to create the gold layer. Let me just run. I did not run bronze to silver. Let me run it, and then I'll run. So again, similar thing. It will create DDLs. It will create ETL code, and then populate the data in that appropriate layer. Now, let's try to create a gold layer. And before that, I like to show you when we are performing the ETL work from silver to gold, we are actually changing the data model. And the kind of prompt you require is like this. So you have an OLTP application and you want to convert into OLAP. You're providing the context for the model. And then you are also specifying OLAP application data model should be created in star schema. And then there is an example how the star schema looks like in terms of fact and dimension tables. So this is the kind of prompt engineering you have to do to create the target schema for the gold layer. And then you would have the ETL script that would populate by transforming the data from silver to the gold layer. And let's see how it goes. And I'll also show you exactly how the data looks like for each layer in the database. So we want to run silver to gold, and whatever is there in that Python script would then be executed. You will create a consumption layer. So you require the DDL, the data definition language, which is nothing but a set of instruction to create tables and all that. And then sometimes it doesn't work as expected, but I ran it before and I'm able to show you the target consumption layer. And once you do that, probably the next stage would be to create a semantic layer. Okay, don't worry, it ran last time and I've got the consumption layer DDL and consumption layer code, which is the ETL pipeline code, and you can see it is performing, and this code was generated by Python. Code generated the code to do this transformation. Now after that, what you probably would do, you would like to create the semantic layer, which is the first script, which is this is kind of hard coded. I'm focused around some predefined KPIs. You can actually customize it where it can really take input from you. Again, same error, that's fine. So let me show you how these layers look like. If we look at the source database, you had these many tables. the staging is just a copy of it. I've just prefixed staging just to differentiate. Now, it is basically an extraction of data from these tables to into the staging table. That is precisely what you do. Since we have used GenAI, it supports any number of tables. Probably the execution time will vary depending on the number of tables and the data in it. But at the end, you will get a mirror image of your source data. Now, if you look at the silver layer, which is curation layer, it is the same set of tables. The only difference is the data quality is much better. You may have lesser rows. Probably you'll have some columns populated through GenAI. Now, if you look at the consumption layer, which is the gold layer, what you see here, a lot of dimension and fact tables. Now, this is basically in the prompt you specify what dimension you'd like to see and the facts, and that is basically is a different model. This is in a star schema, and from there you create what is called a semantic view. And I'll just show you how the data looks like in the semantic view. So I've created an CSV file which has a lot of information for a given domain. These values are going to be analyzed. So what I'm trying to demonstrate here is how you can leverage GenAI to perform all that without having to do much, and that way you leverage the code generation capability. So what essentially we have done, we have generated the code to create target databases through DDL scripts, and then we also created, using prompt engineering, the code that will extract data and populate that particular layer. This is months of job if it is a large application, and GenAI makes it really very efficient. So basically months becomes days and weeks. That's the productivity gain you have. We've discussed about the semantic layer. It organizes the data, abstracts, provides a business view of the data. And this is the screenshot where I ran it successfully. Now, just to summarize what we have done, we had some data sources, used GenAI to create bronze, silver, and gold layer. Bronze and silver were relational model, whereas the gold layer is essentially a denormalized. It is still hosted in form of tables, but the data is aggregated and presented in either Snowflake or scar schema. And out of that, you create a semantic rail. That is what we will be using. Now, why did we go through all that? What is the reason where you basically pull out data, undergo all the stages of ETL, and create a semantic layer? The goal was to really essentially generate insights by looking at the data, doing some analysis, and get a view to make marketing strategies or production strategies, whatever the key decision maker needs from a data analysis and visualization. Now, again, for that purpose, you can leverage GenAI as well, like you did it for ETL. Here, you can use it for visualization, and Microsoft has created a set of libraries called LIDA, and that basically helps you write code to generate visualization in an automated manner. Again, we are using GenAI's capability for code generation. The objective here is to take that semantic real data and then present it in the form of visualization. So LiDAR has 4 capabilities. There are 4 modules. The first module is called Summarizer, that converts data into a rich but compact natural language summary. So you really want to understand what the data is about. And after that, it'll help you enumerate or guide to build visualization goals. Now, what do I mean by visualization goals? It is essentially how you should look at the data, and then again, GenAI does the work for you and presents you how you should look at the data from different perspective, which is called goals. And you can all add your own goals. GenAI is actually looking at the data and coming out what are the different ways you can look at the data. And then the module called Vis Generator helps you create the visualization code that would really be presented in the form of different style of visualization. And finally, the infographer. Now, let's just spend 1 minute in terms of the capabilities. LiDAR helps you summarize the data, provides you an exploration in an automated way to create visualization and infographics. Now, while it is doing that, it also provides you the explanation, evaluation, and recommendation on how you should see your data. Now, let's see it, because I believe without seeing it, it will become very theoretical. So let me just, again, Python code. This code is not been written by me. I've just taken out this code, customized it a little bit so that I can show you. So all that is provided without having to do much. And let's look at it. So if you see, you can choose the model that you want to use. So I'm using GPT-4. You can set the temperature. I've enabled cache so that if I ask the same thing, then the data comes from the cache instead of going to the model. You choose the data set. So I've got some sample data sets, and let me just show you the code. So I've got cars, weathers, and tightening data sets available either in JSON or CSV form that I'm using. And this is just a simple application. So let's look at cars. So I've selected it as data set, and you can see here it has summarized the data. It really looked at the data, what are the different values, the column names in that, what are the data types, the standard, minimum, maximum values for numeric. So this gives you some sort of a summary of the entire data set. After that, it will leverage GenAI to create the visualization goals. So there are 4. One can actually choose the number of goals you want the GenAI to create. And these are the 4 goals. What is the relationship between retail price and dealer cost across different car types? Not only it is doing that, it is actually giving the explanation, like I said before in the presentation, what kind of questions it can answer, the rationale behind it, and the kind of visualization. What type of visualization is suitable here? And then again use GenAI. It will use visualization library. There are 4 to 3 libraries which are supported. And let's use matplotlib, which is what I've been using. Error. That means the code is real. And it will also show you again the explainability aspect, the code to create those visualization. Now let's take another data set. Let me just go up. Let's choose Titanic. So that data set, which is the result of the ETL process, is used to create the summary. It will show you the distinct values in terms of gender, the age brackets. Also helps you create the goals and a corresponding visualization for that goal after explaining. So one can actually choose, like I said, you can choose the number of goals. Say for example, if I say I want it to be 10, it will generate these many goals. These are the ways you should, for example, what is the survival rate by port of embarkation? And based on the goal that you've chosen, what you get is a visualization. And behind that, what was the code used to create that visualization? Now, if you happens to be in business intelligence kind of domain, you can actually understand this is entire end-to-end analytics, and you can actually see how GenAI can do wonders in terms of creating the whole stack without having to write all that. And like I said in the beginning, it is agnostic to the domain, whether you're running in sales, marketing, inventory, and it is also agnostic to the database format and the database type, the number of tables. It is basically sifting through the entire database, creating those different layers, and then on the symmetric layer, you can actually build visualization. You have option to add your goal. Like I said, you can upload your own data if you have some semantic layer data and you want to visualize. So these are 2 independent projects that I've done, so that depending on the need, if you just want to do ETL or visualization or both, it's up to this. The key message through this demonstration is how one can make use of GenAI for such use cases. And the final stage, you can actually create beautiful infographics, but that is not what I have. So that's pretty much, you can actually see through this practical use case. It is still experimental in the sense this is not production grade. It is just a proof of the capability of GenAI for such use cases. like business intelligence. Thank you. See you next week.